Imagine a trampoline. When you place a bowling ball in the center, it creates a dip. This dip represents how massive objects warp the fabric of space. Now imagine time as part of this fabric, bending and stretching alongside space. This combined fabric is what we call space-time. It's a mind-bending concept, but it's fundamental to understanding the universe. Our everyday experiences make it difficult to grasp this flexibility. We perceive time as a steady flow, always moving forward. But Einstein's theory of relativity showed us that time is relative, not absolute. It can be influenced by gravity and speed. Just as the trampoline dips under the weight of the bowling ball, time can be warped by massive objects. This warping of space-time is what we experience as gravity. The Earth warps space-time around it, causing objects to be pulled towards its center. The more massive an object, the greater the warp it creates, and the stronger its gravitational pull. This understanding revolutionized our view of gravity, moving beyond Newton's simple attraction to a more complex interplay within the fabric of space-time. The flexibility of space-time opens up a world of possibilities, including the concept of wormholes. These hypothetical tunnels through space-time could potentially connect distant points in the universe, allowing for faster-than-light travel. While still theoretical, the concept highlights the potential for incredible phenomena within the flexible fabric of reality. Space-time is the four-dimensional fabric of our universe, a concept that fundamentally changes how we perceive reality. It combines the three dimensions of space length, width, and height into a single framework, and then integrates the fourth dimension of time, creating a seamless continuum. Instead of thinking of space and time as separate entities, we now consider them as interwoven aspects of a single, unified continuum. This unified concept is crucial for understanding the nature of gravity and the behavior of objects in the universe, from the smallest particles to the largest galaxies. Einstein's theory of relativity revolutionized our understanding by showing that space and time are not absolute, but are relative to the observer's motion and the presence of gravitational fields. This means that time can pass differently for two observers depending on their relative speeds and the strength of the gravitational fields they experience, a phenomenon known as time dilation. The faster you travel, the slower time passes for you relative to someone who is stationary, a concept that has been confirmed through various experiments. Similarly, the stronger the gravitational field you are in, the slower time passes for you. This effect is especially pronounced near massive objects like black holes. This effect has been experimentally verified and is crucial for the functioning of GPS satellites, which need to account for the time dilation due to their motion and the weaker gravitational field they experience in orbit. Without accounting for these relativistic effects, GPS systems would become inaccurate very quickly, leading to errors in navigation and timing. The concept of space-time allows us to understand the universe in a more fundamental way, providing a comprehensive framework for the laws of physics. It provides a framework for describing the motion of objects and the propagation of light, which is essential for our understanding of the cosmos. It also opens up the possibility of exotic phenomena like wormholes and time travel, though these remain largely theoretical at present. These concepts continue to inspire scientists and fuel our imagination about the future of space exploration and our understanding of the universe. A timeline is a way of visualizing the passage of time. It's a sequence of events arranged in chronological order. We use timelines to understand history, plan projects, and track progress. In the context of space-time, a timeline represents the path an object takes through the four-dimensional fabric of the universe. Each point on a timeline corresponds to a specific event in space-time. This event is defined by its location in space, its coordinates, and its time of occurrence. As an object moves through space-time, it traces a path, creating its own personal timeline. This path is influenced by the object's velocity and the gravitational fields it encounters. Imagine a car traveling along a road. The road represents the timeline, and the car's position at any given moment represents an event in space-time. As the car moves, it traces a path along the road, creating its timeline. Similarly, every object in the universe traces its own path through space-time, creating its unique timeline. Timelines can be complex and intertwined. Different objects can have different timelines, and these timelines can intersect and influence each other. The interactions between different timelines create the rich tapestry of events that make up the history of the universe. A tesseract is a four-dimensional analog of a cube, a concept that stretches our imagination beyond the familiar three dimensions. Just as a cube is a three-dimensional representation of a square, a tesseract is a four-dimensional representation of a cube, extending the idea of dimensions further. It's a challenging concept to visualize because we are limited by our three-dimensional perception, making the fourth dimension seem almost mystical. However, we can use analogies and mathematical models to understand its properties. Imagine a square, a simple two-dimensional shape. If we extrude it into the third dimension, we get a cube, adding depth to the flat square. Similarly, if we extrude a cube into the fourth dimension, we get a tesseract, a shape that exists beyond our direct experience. A tesseract has 8 cubic cells, just as a cube has 6 square faces, expanding the complexity of its structure. It has 24 square faces, 32 edges, and 16 vertices, each adding to its intricate geometry. These properties can be derived mathematically even though we cannot directly visualize the object in its entirety, relying on abstract thinking. One way to visualize a tesseract is to imagine a series of nested cubes, each fitting perfectly within the other. Start with a small cube inside a larger cube, a simple yet powerful analogy. Connect the corresponding vertices of the two cubes, creating a bridge between dimensions. This creates a representation of a tesseract projected into 3 dimensions, a shadow of its true form. While not a true tesseract, it gives us a glimpse into its structure, offering a tangible connection to the abstract. Another way to understand tesseracts is through their unfolding, revealing their hidden complexity. Just as a cube can be unfolded into a two-dimensional net of 6 squares, a tesseract can be unfolded into a three-dimensional net of 8 cubes, each representing a part of the whole. This unfolding can be visualized and manipulated to gain insights into the tesseract's structure and properties, allowing us to explore the fourth dimension in a more intuitive way. Our brains are wired to perceive the world in 3 dimensions, a fundamental aspect of our everyday experience. We can easily understand length, width, and height, the basic building blocks of our spatial awareness. However, visualizing higher dimensions like the fourth dimension represented by a tesseract presents a significant cognitive challenge that stretches our mental faculties. Our senses and intuition are simply not equipped to directly grasp these higher dimensions, making them elusive and abstract. Imagine a two-dimensional being living on a flat plane, confined to its limited perspective. It can only perceive length and width, unable to fathom the concept of height. If a three-dimensional sphere were to pass through its plane, it would only see a series of circles appearing and disappearing, a puzzling phenomenon. It would not be able to comprehend the sphere as a whole, just as we struggle with higher dimensions. Similarly, we struggle to comprehend a tesseract because we are limited by our three-dimensional perception, which acts as a barrier. Despite this limitation, we can use mathematical tools and analogies to understand higher dimensions, bridging the gap between intuition and abstraction. Mathematics provides a language for describing and manipulating objects in any number of dimensions, even those beyond our ability to visualize, offering a glimpse into the unknown. Analogies like the nested cubes or the unfolded tesseract provide mental models that help us grasp some aspects of higher dimensional objects, making the abstract more tangible. The challenge of visualizing higher dimensions highlights the limitations of our sensory perception, a reminder of our cognitive boundaries. It reminds us that our experience of reality is filtered through our senses, and that there may be aspects of the universe beyond our direct comprehension, waiting to be discovered. However, through mathematics and abstract thought, we can push the boundaries of our understanding and explore the hidden dimensions of reality, expanding our horizons and deepening our knowledge. Tesseracts serve as a bridge between our three-dimensional world and the realm of higher dimensions. They provide a concrete example of a four-dimensional object, allowing us to explore the properties and implications of higher dimensions. While we cannot directly visualize a tesseract, we can use its mathematical representation and projections to gain insights into its structure. By studying tesseracts, we can develop a deeper understanding of how dimensions work. We can explore the relationships between lower and higher dimensions and how objects in higher dimensions interact with lower dimensions. This understanding can be extrapolated to even higher dimensions, even though they are even more difficult to visualize. Tesseracts also play a role in theoretical physics, particularly in string theory and other theories that propose extra-spatial dimensions. These theories suggest that our universe may have more than the 3 spatial dimensions we perceive. Tesseracts and other higher dimensional objects provide a framework for understanding the geometry and topology of these extra dimensions. The concept of tesseracts challenges our intuition and expands our understanding of space and dimension. It shows us that there are possibilities beyond our everyday experience and opens up new avenues for exploring the fundamental nature of reality. Thank you for watching Time Pilgrimage, and as always, please remember to subscribe and like. If there is a topic that you would like to explore, please drop a comment.